Hello all, I am Savaka Vishal from class 12th and today I am going to discuss about non-stereochromatic defect, and under this defect we will be talking about metal excess defect as well as metal deficiency defect. First of all, looking towards the metal excess defect, we have two types of metal excess defect, and first one is your metal excess defect due to anionic vacancies. Now from the heading only, we can describe it by the heading only. As the heading suggests that it is this defect is due to the anionic vacancies, and anions are the negative ions you all know. So this defect must be something about in which there is some vacancies in the anions. So let's talk about this defect by taking an example. So we have taken an example of NaCl crystal. This is an NaCl crystal. You can see in this picture. So here the chlorine atoms are represented by blue atoms, and Na atoms are represented by this orange atoms. So you know that anions are chlorine. So what we have done in this experiment is that we have put this crystal in a sodium vapored container. So when we put it in a sodium vapored container, the sodium vapors, they get absorbed on this surface, on the surface of this crystal. Thus, as sodium vapors are absorbed on this surface, the chlorine atoms inside the crystal gets drifted towards the surface, and thus it creates some anionic vacancies, or it creates some vacancies of this negative atom, of this anion. And due to this vacancy, the sodium atom, which is positive in nature, which is metallic in nature, that donates its electron, gets isolated, and as it donates its electron, it have a free electron, and that electrons get accumulated at some sites, and we call that sites as F centers. In Greek, it had come from a Greek word known as Farvengenter centers. So these sites will be promoting some colors to this crystal. Now when some light we can see any object in the universe. We can only see any object in the universe only when some light is falling into it. And when we're gonna see this crystal, that means some light is falling on this. So when some light is falling on this, these electrons at the F centers, this get energized, and that propagates some colors, and that radiates some colors. Like for NaCl crystal, after this experiment, for NaCl crystal will be radiating blue color. Similarly, if this experiment is done with the LiCl, it will be radiating pink color, and if this experiment is done with the KCl, it will be radiating violet color respectively. Now looking towards the next experiment is the metal excess defect due to presence of extra cations at interstitial sites. So here we will be talking about the extra cations at interstitial sites. You know, interstitial sites are the free sites, they are the vacant sites in a solid crystal. So when some extra cations, I mean the positively charged ions, are present in the interstitial sites, this defect is seen. So let's take an example of a zinc oxide crystal. In this crystal, it is a perfectly ordered crystal. So we need to create cationic sites. So that means we need to remove those anions as we have done in the previous experiment. So when it is heated, when zinc oxide is heated, the oxygen from that crystal lattice gets separated out, it gets vaporized. So due to which these extra cations are left over in that crystal lattice, and this defect is created. Next, looking towards the metal deficiency defect. So here there is some deficiency. Here we can say there is some deficiency in metals, or we can say there is some deficiency in charges. Rather, we can say we can say so there is some deficiency in metals. For a solid, we know that the net negative charge is equal to the net positive charge. Hence, for a solid like FeO, you know, Fe have two isotopes, Fe2 plus and Fe3 plus. One is ferrous and another one is ferric. So for a crystal of FeO, there are some some impurity, we can say some impurity of Fe3 plus crystal that gives an extra positive charge to the iron crystal, and due to which the percentage of ferrous, the percentage of Fe in that crystal is quite less. So we can say that there are many examples. For example, we can say a crystal of FeO where oxygen is 100% and Fe is